All right, so now we want to look at solving rational inequalities. And you'll remember that in algebra, when we talk about rational, we mean fractions, right? Fractions where you have algebraic expressions on top and the bottom, and we're trying to figure out when these things are bigger than or equal to a value. Um, so these are going to have some similarities to solving polynomial inequalities. But they have some initial setup differences that we've got to make. So when you come across one of these, the first thing you want to do is, just like polynomial inequalities, you want to be dealing with it when it's greater than or equal to 0 or less than or equal to 0. So you want to move everything on one side so you have just a 0 on the other side, and that's what we've got here. These are both on the same side, and you've got a 0 on the other side. The other setup you've got to do is you're not we can't do what we need to do when there are two fractions. So we need to combine these, right? This is, in this situation, it's a fraction minus a fraction. So I actually need to subtract these two fractions so that I end up with a single fraction being greater than or equal to 0. So I've got to use my what I know about working with rational expressions to actually do this subtraction. So we know that if I want to do this subtraction, we've got to have common denominators. And so what we need to realize is we're going to need to multiply this by x minus 5 and x minus 5 on the top and the bottom, right? The x minus 5 coming from there. In order to get a common denominator, which is going to be x plus 4, x minus 5, you're going to want to multiply that one by x minus 5 by x minus 5, this one by x plus 4, x plus 4. So it's going to look like this. When the first numerator is going to be x minus 3, x minus 5, and then the second numerator is going to be x plus 2, x plus 4, and we're subtracting those. And since they are the same over the same denominator, we can write them now over that common denominator. And we want to know when that is greater than or equal to 0. So we're not quite ready. We need to simplify this, and most of the simplification is going to happen up here. We need to expand it and combine like terms. So let's just kind of do that right here. We'll FOIL these two out above one another. So this one becomes an x squared. It's going to become a minus 8x plus 15. And then minus, this one's going to become an x squared plus 6x plus 8. And then when I combine them, the x squareds, right, look carefully, watch this sign distribute through and see what we get. On the top, we're going to have x squared minus x squared. Those are going to be gone. Minus 8x minus 6x is a minus 14x. Let's do it right here. It's going to be a minus 14x, and then 15 minus 8 is a plus 7. So minus 14x plus 7, it looks to me like I can factor out a negative 7 from both of those, leaving x, or 2x, minus 1. That is that, factoring negative 7 out. And that's our numerator. It's more simplified. And so let's put it here. And then the denominator is x plus 4, x minus 5. So now we're finally set up to solve this rational inequality. All right, so the process is this. Now, once you get to this point where you have a single fraction being greater than or less than 0, then you're ready to kind of proceed like we did with polynomials. You want to look at the top and the bottom and determine what the zeros of the top and the bottom are, right? So the top, the 0 of the top is a 1/2. So let's write these down. So x equals 1/2 is 0 from the top, or negative 1/2. Right, what makes that 0 is a 1/2. x equals negative 4 from the bottom and x equals 5 from the bottom. And we want to put these on a number line. So negative 4, 1 half, and a 5. And now we've got 3 sections. Now, before we do this, I want any zeros that come from the denominator, I'm going to put a little asterisk by. So the negative 4 and the 5. I'll tell you what that asterisk is here in a second. But basically, the zeros from the denominator, I'm going to put a little asterisk by, because they get treated a little bit differently than the 1 half. But at this point, I can use either of the same methods that I used with solving polynomial inequalities. So I can pick test values and plug them in the entire thing. So for instance, I would say pick a number in here, say 0, and plug it in there and see if it's a solution. Right? I have to plug it in carefully for all the x's and do all the multiplication and see if you get out a positive number or a negative number. And then I would do that for the other 3 intervals. Pick something in there, say a 1 or a 2, plug it in. Let's do it the kind of fancy way where we come along and we say, let's just look at the individual factors. So I'm going to do that here. I'm just going to put my factors down. So don't forget, you got to include the minus 7. And minus 7, if I just consider minus 7, it's negative regardless of what the test value is, right? Because it's always negative 7. Okay, let's use now at the 2x minus 1. It's going to be negative here, right? Plug a negative number in, say a negative 5, you're going to get a negative 11. Negative there, and it's going to swap at 1 half. So it's negative, negative, positive, positive. It swaps at 1 half. For x plus 4, it's going to be negative here, right? Plug in a negative number. You're going to get out a negative number, but it's going to swap at minus 4. So it's going to turn positive. And then finally we go x minus 5. And the same game. It's going to be negative, 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 swap at 5, and become positive. And so all of the factors are in there. Now look, you've got all of the factors are either multiplied or divided. So in this region, you're going to have a negative times a negative on top over a negative times a negative on the bottom. In the end, it's going to be positive. Here, you'll have a negative times a negative on top divided by a positive times a negative, or just count the signs. It's going to turn into a negative. This will be a positive. This will be a negative. So where are our solutions? Well, we wanted to know when we were greater than or equal to 0. So that would be this region and this region. Right? Those are our 2 positives. Now the tricky part is the endpoints. Greater than or equal to. Because of the equal to, we will include some of the endpoints, and the rule is this. You can include the endpoints that come from the numerator, but you can't include the endpoints that come from the denominator. That's why I put a little asterisk next to negative 4 and 5, to remind myself that I can't include those. So my solution in the end is everything from negative infinity to negative 4 combined with in 1 half, including 1 half, up to 5, not including 5. And that's our solution for this inequality.